Okay, it's time to get started for section 1-3 for geometry, and it's called measuring segments. So yesterday we talked a ton about vocabulary and symbols and how we write things down. Today we're going to focus a lot on just segments themselves because we can do so many things with them. So first of all, I'd like for you to be able to find the distance between two things, and I'd like for you to be able to know the midpoint between 2 points on a number liner when given two lengths, okay? So first of all, we need to kind of define some more things, and then we'll be able to move forward. Congruent segments. Congruent is a huge word. This is not going away. We're using this for the whole time in geometry. Congruent basically means same value or same length, same measurement. So congruent just right there means same measurement. Okay. Now, congruent segments are when two segments have the same exact length. All right, I want to tell you a few things. First of all, note. Line segments are congruent, not lines. We do not say that line AB is congruent to line XY because they both go on for forever, and so that doesn't really have an incremental measurement or value to it other than infinity. So we use congruent for segments, not lines. Also, I am not going to keep writing out the word congruent over and over and over again. There is a symbol for that, just like we have symbols for addition and subtraction and equals. So the symbol for congruent is two lines with a squiggle over it. So that means congruent. All right. Now, if you have an image, because we have a lot of pictures in geometry since we work with shapes and lines and things like that, we might have two segments, and let's just draw some out real fast. This is segment DE. This is segment LM. Okay, if you saw this image, unless you were told in the problem, you would not be able to say, yes, those are congruent. We would need a way to mark that they are congruent. We do that with tick marks. So we can put a single tick mark on each of them showing that they are congruent now, so then we can conclude that. We need to have an equal amount of tick marks though, so I'll make a little note of that. An equal amount of tick marks means congruent. All right, so for example, maybe we have three other line segments over here. I'll call this one XY, this one RS, and this one, I don't know, KF. All right, if I were to put a single tick mark on this, then that now means that XY, LM, and DE all have the same length or the same measurement. If I put two tick marks on KF and RS, that means that these two are congruent to each other, but they are not congruent to these three guys. Don't think that the more tick marks means the longer either. That's just the way it worked out. It's just if they have a matching amount, then they're the same length or measure. All right. Moving on, we have something called a segment addition postulate. So, what is a postulate, first of all? It's very similar to a theorem or a law. However, we cannot prove these. There comes a point where we just have to take certain things for granted. Like, we can only simplify stuff so much until it's like, well, we can't really describe this anymore other than we know it works, we know it's a thing, so we will just make it a postulate. It's like the most fundamental thing you can have. So, in our segment addition postulate, it says if 3 points are on a line, and B is in the middle of A and C, then AB plus BC is equal to AC. All right, there's a couple things I want you to notice right now. First of all, I did not put lines on top of these. When there is no line at all, that means the length. So that means the length of AB plus the length of BC is equal to the length of AC. If I were to put the line across, then that would be segment AB instead of length AB. Also, the letters don't actually, like you could have used X, Y, and Z or whatever. I just chose A, B, and C for this. Let's draw a picture so you can kind of see what that means. First of all, we have a line segment. And when you see this, some of you might be thinking, okay, why did we have to write this out? Well, we have to have our ground rules, like our foundational rules for geometry. So we have point A and C at the end points, and B is in the middle. Well, all we're saying is, hey, these two segments are right next to each other. So if I take AB, so from here to here, and I add it from to B to C, then I'm going to get the whole thing across, which is AC. So that's all that means. If you have two segments right next to each other, you can add them up and get the total length. Okay, now we're getting a little more specific, something called a midpoint. You guessed it. A midpoint is a point that falls right in the middle. So it is a point that divides a line segment. Once again, it has to be a segment. We cannot divide a line in half because half of infinity is still infinity. So it has to be a line segment, a point that divides a line segment into two congruent halves. Remember, congruent means equal lengths, same measurement. So it's very similar to the word equal, but it's representing more of a figure's value rather than a numerical value. So it separates a segment into two congruent halves. Bisect and bisector are very, very similar to this. To bisect means to cut into two even halves. Or congruent halves. Now a bisector is the point, the line, the ray, or the segment that bisects a segment. I'm going to say something because you can bisect more than just a segment. Okay. These three things look very, very similar to the untrained eye. So what is the difference? All right. First of all, bisect versus bisector. This is just a verb versus noun type thing. So the bisector bisects something, just like a plow plows a field. It's the same word, but it's used as a different form of speech. Okay, or part of speech, I guess I should say. So that's one element of the difference. Also, the midpoint is the actual spot that a bisector goes through. So kind of an example of this would be if you cut a slice of cake in half. Okay. The midpoint is the cut itself, but the bisector is the knife that did the cutting. Okay, so the bisector is doing the cutting of the segment. The midpoint is the very spot that that line or ray or whatever it was went through. So that would look like this. If we had, say, line segment XY down here, that's a Y, and let's say that we have ray, and it doesn't have to be perpendicular to it. It could go through it like this. And I'll just call that line L, whatever. And that cuts that perfectly in half, like so. So these two are now congruent to each other, and the midpoint is point M right here. So line L is the bisector, M is the midpoint. Hopefully that's making sense. Let's put that into practice on the back of the page. It says use the figure to the right, and we're going to find some of the values of this stuff. Okay. So first of all, we're trying to find BC. There's no line above BC, so it's basically saying find the length of BC. Well, we can easily just count, and so it's just going to be 2 long, 2 units, 1, 2. Then we're going to find from A to C, okay, from A to C. 1, 2, 3, 4, 5. It is 5 units long, and it's as simple as that. Just had to count on the number line. Next, example 2, it says if G is between F and H, and FG is equal to 6, and FH is equal to 11, find GH. Okay. Draw out what you know. G is between F and H, and if you don't get it perfectly, I don't know, like to scale, it's fine. So we have these points, and we know G is in the middle somewhere. So there's G, and F and H are on either sides. Then it says the length of FG is 6. So from here to here is 6, I don't know, inches, units, whatever. And from F to H is 11. So all of this, all the way from F to H, is 11. We're trying to find GH. So I will highlight that for you. We're trying to find the length from G to H. Well, if I know that the whole thing is 11 and part of it is 6, I can take 11 minus 6, getting me 5, which that is going to equal the length of GH. And we're done with that. Now we're going to apply this very same concept that we used in example A, and we're going to use it in example B, but now we just have a little bit of algebra in there. We're gonna, once we set up our equation, it should be easy because it's just plain algebra. So it says find the value of X and the length of each segment using the figure to the right. So here's what we know. We know from N to m is 17. From m to o is 3x minus 5. And the whole thing is 5x plus 2. What we can do is say this thing plus this thing is equal to the whole thing. So that's what we're going to do. We're just going to set up that equation. So we have 17 plus 3x minus 5 is equal to the whole length. And the whole length is 5x plus 2. It's okay that we have variables in there because we can still solve for it. Now we're just going to start through with combining like terms and just how we would solve any other algebra expression. So I know that I can combine 17 and minus 5, so that's going to get me 3x plus 12 is equal to 5x plus 2. Now I'm going to subtract 2 from both sides of the equation. Those cancel. I'm left with 3x plus 10 is equal to 5x. Now I'm getting my variables all on one side of the equation. I have 10 is equal to 2x. Divide by 2 on both sides, and I have x is equal to 5. Okay, that is very valuable. We have now done this part of our problem. It said find the value of x. We got it all taken care of. Then it says find the length of each segment. So that means from n to m, from m to o, and the whole thing. Well, we already know the length of nm. That's easy. It was given to us. So the length of nm is equal to 17. Got that. To figure out the length from m to o, all we have to do is take this x equals 5 and substitute it back into our expression. So we have 3 times 5 minus 5, which that's equal to 15 minus 5, which is equal to 10, and that was MO. So the length of segment MO is equal to 10. And once again, how I did that was I took the x value that I solved for and I substituted it in. Now to figure out the whole length, you have two options. You can either say, oh, 17 plus 10, because I already figured out what that is, getting me 27, or you can take this 5 and substitute it in here. We'll do it both ways. So 17 plus 10 is equal to 27, which is equal to the length from N to O. But if you want to check your work, you can plug it in there. So 5 times 5 plus 2, which that's equal to 25 plus 2, which is equal to 27, and it still matches. So this was a little bit more complex, but remember, all you have to do with the segment addition postulate, this part plus this part is going to equal the whole thing. So then you just use the expressions and substitute those in. All right, for the very last one, it says, the map shows the route for a race. You are at X, 6,000 feet from the first checkpoint, C. The second checkpoint, D, is located at the midpoint between C and the end of the race, Y. The total race is 3 miles. How far apart are the two checkpoints? This is a pretty wordy problem, but we're just going to break it down one step at a time. So first off, it says the map shows the route for a race. You are at X, so this is the start. And it is 6,000 feet from the first checkpoint, which is C. So right off the bat, we know we have 6,000 feet from X to C. I'll go ahead and put the feet symbol in there. It says the second checkpoint, D, is located at the midpoint between C and the end of the race, Y. So D is in the very center of C and Y, meaning that we now know that this small section and this small section are congruent to each other. Remember, congruent meaning the same value. So I am going to put a little symbol in there representing that they are congruent. I also know that the total race is 3 miles. Okay, so from X all the way to Y, that's going to be 3 miles. But because we were given 6,000 feet here, it might be best to just go ahead and convert that to feet. So there are 5,280 feet in a mile. Take that multiplied by 3. It's going to get me 15,840 feet. That's the total, this section right here. All right, so what we want to do first is to figure out how far it is from C to Y. The way we're going to do that is by taking this excess 6,000 feet away from the total. So my first step is to take 15,840 minus 6,000 feet. When I do that, which I work this off to the side, but you might need a calculator, it's going to be 9,840. This 9,840, let me find my highlighter again. This number corresponds to this distance. I want to know how far apart are the two checkpoints, and I think they mean, this wasn't super clear, how far apart is C to D. So let's figure that out. Well, if I know the total and I know that the two halves are congruent, then I can just take the total and divide it by 2. So I have 9,840 divided by 2 is going to equal 4,920 feet. That's the distance, and we're done. When you see word problems like this, I just encourage you to read it one time through and then read it a second time, and that's when you start breaking it down piece by piece. Once you get an image drawn and you understand what's going on, they're usually not too tough. If you have questions, make sure you bring them to me tomorrow in class. Have a good night.